Hello everyone, I'm Hossein Azizullahi and welcome to Pragmatic Programming channel. Let me give you an overview of what you're going to learn and how I have structured this video. At first I will talk about why should you learn C#, and then I will talk about the fundamentals of C# and .NET. One of the questions that most beginners ask is what the difference is between C# and .NET, so I'm going to cover that. I'm also going to talk about CLR, assemblies, namespaces, IL code, and stuff like that.
So let's start with a simple question. Should you learn C# in 2022? The short answer is absolutely yes, because the enterprise uses it and it has a perfect future ahead. It's 100% cross-platform, which means write it once and run it everywhere. It has an amazing IDE for commercial use called Visual Studio. It's 100% open source. It has tons of free library to almost anything, including machine learning, building web application, mobile application, smartwatch application, TV application, and many more. As of .NET 6, its performance compared to other languages like Java, Python, Kotlin, Scala is skyrocketing. Okay, now what is .NET and how is it different from C#? Some developers who are absolutely new to C# don't know the difference. So in this video, I'm gonna talk a little bit about C# and .NET. C# is a programming language. .NET is a framework for building applications. .NET is not limited to C#. There are different languages that can target .NET and building applications using that framework. Examples are F# or Visual Basic .NET. Okay, now, but what exactly is .NET? .NET consists of two components. One is called CLR, or Common Language Runtime, and the other is a class library for building applications. Okay, before we understand what CLR is and why we need it, let me explain a little bit about the history of C#. Before C#, we had two languages in the C family, the C language and C++. With either of these languages, when we compiled our application, the compiler translated our code into native code for the machine on which it was running. Which means if I wrote an application on a Windows machine with 8086 processor architecture, the compiler would translate my code into the native code for that machine that is a Windows machine with an 8086 processor. Now we only have different hardwares and we have different operating systems. So if I took the application that compiled the application on the computer with a different architecture, that would not run. So when Microsoft was designing the C# language and the .NET, they came up with an idea that they borrowed from Java community. In Java, when you compile your code, it's not translated directly into the machine code. It's translated into an intermediate language called bytecode. And we have the exact same concept in C#. So when you compile your C# code, the result is what we call IL, or intermediate language code. It's independent of the computer on which it's running. Now we need something that would translate that IL code into the native code or machine code that is running the application, and that is the job of CLR, or Common Language Runtime. So CLR is essentially an application that is sitting on the memory whose job is to translate the IL code into the machine code, and this process is just-in-time compilation, or JIT. So with this architecture, you can write an application in C# and you don't have to worry about compiling that into the native code for different machine. As long as that machine have CLR, that machine can run your application. Okay, now let's talk about the architecture of .NET applications at a very high level. When you build an application, your application consists of building blocks called classes. These classes collaborate with each other at runtime. As a result, the application provides some functionality. Now, what is a class? A class is a container that has some data, which is also called attributes, and functions, which is also called methods. Functions and methods have behaviors. They do things for us. Data represents the state of the application. Let me use an example. Think of a car. The car has some attributes like its make, its model, its color. These are the attributes of a car. A car also has some functions. We can start it or we can move it. So we can think of a car as a class in a real-world application. We have 10, hundreds, or even thousands of classes responsible for a piece of functionality. An example of that is classes that are responsible for getting the data from the user, process the data, and display something to the user. Now, as the number of classes in an application grows, we need a way to organize these classes. That's where we use a namespace. So a namespace is a container for related classes. For example, in .NET, we have namespaces which containing tens of related classes. We have namespaces for working with data like databases. We also have namespaces for working with graphics or security. Now, in the real-world application, as these namespaces grow, we need a different way of partitioning our application. And that's where we use an assembly. An assembly is a container for related namespaces. Physically, it's a file on the disk, which can either be an executable or DLL, which stands for Dynamically Linked Library. So when you compile an application, the compiler builds one or more assemblies depending on how you partition your code. In the next video, we will start our first application using C#. Thank you for watching this video. Leave a like if you like this video and subscribe to my channel and hit the ring button so you will be notified once I publish my next video. Bye.